Artificial intelligence is reshaping the way humans think, operate, and live. Artificial intelligence allows machine to imitate a form of human intelligence by making the machine sense, reason, act, and adapt to its environment. If efficiently deployed, it would lead to substantial improvements, whether it's in decision making or value creation. But what you should first bear in mind if you want to dive into AI is that AI is a field that is continuously evolving, and that the effort you'll be deploying now to bring an AI solution to life should also evolve over time. So it's not a do once, use for everything. 5 years from now, the whole AI field will look much different than it does today. Techniques and algorithms that are currently considered cutting edge will have become outdated and maybe obsolete, and you will have to be aware of this and be ready to always stay up to date, and this requires, of course, huge engagement and also investment. AI and its implications require us also to be more thoughtful, to aim not just at solving a particular problem, but to first make sure that the problem we're aiming at is the right one. Now let me share with you some exciting areas of AI which, according to Forbes, will have a flourishing future and will unlock amazing opportunities. The first area is unsupervised learning. The dominant paradigm in the world of AI today is supervised learning. In supervised learning, we want to teach the computer how to do something, then let it use its newfound knowledge to do it. In contrast, in unsupervised learning, we let the computer learn how to do something and use this to determine structure and patterns in the data. So you're just told, here is the data, can you structure it? Can you find patterns in it? Efforts to apply unsupervised learning to other areas of AI remain till now at earlier stages. And many AI leaders see unsupervised learning as the greatest challenge in machine learning and artificial intelligence in the next few years. The second interesting area of AI is federated learning. As you already know, the standard approach to building machine learning models today is to gather all training data in one place, often in the cloud, and then to train the model on that data. So rather than requiring one unified dataset to train a model, federated learning leaves the data where it is, distributed across numerous devices and servers on the edge, and use this data. Potential applications of federated learning include almost all AI applications that involve sensitive data, from healthcare applications to financial services and autonomous vehicles. Expect federated learning to become an important part of the AI technology stack in the next few years. The third promising area in AI is transformers, and here we have entered the golden era for natural language processing. OpenAI's release of GPT-3 and China's the Wudao 2.0 model captivated the technology world. They can write impressive poetry, generate functioning code, compose thoughtful business memos, write articles about themselves, and so much more. GPT-3 was trained on roughly 500 billion words and consists of 175 billion parameters. Wudao 2.0 model was trained using 1.75 trillion parameters. So expect transformers to serve as the foundation for a whole new generation of AI capabilities in the years ahead. The fourth exciting area of AI is System 2 reasoning. But before talking about System 2, let me first introduce System 1. System 1 is the brain's fast, automatic, intuitive approach. System 1 activity includes the innate mental activities that we are born with, such as preparedness to perceive the world around us, recognize objects, recognize faces, orient attention, etc. System 2 is the mind's slower, analytical mode, where reason dominates. Usually System 2 activity is activated when we do something that does not come naturally and requires some sort of conscious mental exertion. Today's cutting-edge AI systems excel at System 1 tasks, but struggle with System 2 tasks. So in order to progress, AI needs to get better at System 2 thinking. And of course, no one yet knows with certainty the best way to move towards System 2. The fifth exciting area in AI is generative AI. Generative AI is a fast-growing new field that focuses on building AI that can generate its own novel content. So to put it simply, generative AI takes the artificial intelligence beyond perceiving to creating. Generative AI refers to programs that can use existing content like text, audio files, or images to create new plausible content. Generative AI enables computers to learn the underlying patterns related to the input and then use that to generate similar content. One of the most exciting areas of generative AI is generative adversarial networks, or GANs. There are many applications of GANs. They can transform photo editing and make it easier to add like subtract elements such as background objects, trees, buildings, etc. And here in these examples, I simply uploaded a photo of me and a video of Obama, and the AI generated a video of me speaking like Obama. Now let me share with you some results from research projects I've been coordinating during the past 3 years. The first project I'll be introducing in this keynote was among 45 projects that were accepted for funding in Al-Khwarizmi program here in Morocco. It's the first 100% Moroccan agricultural and computer vision powered robot which performs weeding, harvesting, and soil analysis. Agriculture in Morocco employs almost half of the population. About 57% of women are engaged in agricultural activities, ranging from weeding to harvesting, planting, irrigation, and pest control. They contribute to more than 50% of the agricultural labor. Large number of these women aren't receiving any education at all, with children forced to quit schools to support their families. The massive adoption of technology in the agricultural sector will not only allow agriculture businesses to be more profitable, sustainable, efficient, safer, and more environmentally friendly, but it will also ensure that farmers in rural areas get decent living and decent education instead of spending several hours per day doing highly repetitive and physically taxing labor robots can efficiently do. Our agriculture and power vision robot is to be deployed in a grape field as a first step, and it will perform 3 main tasks: weeding, harvesting, and soil analysis. For the weeding operation, the robot's vision system will allow it to follow the crop lines and detect the presence and location of weeds in and between the rows. Robotic arms can spray chemical herbicides in a targeted manner or determine the necessary force to pull out the detected weeds. For the harvesting operation, the robot will leverage the power of machine learning to locate the crop, determine its type, degree of maturity, and whether it is eligible for harvesting or not. The soil analysis operation makes it possible to know the fertility of the soil, the availability of the nutrients, irrigation parameters, as well as any changes to be made during planting or pre-planting. Data analysis and interpretation are, of course, essential at this level for good decision making. In order to build a deep learning model for such task, we need to train it with data. That is, we need to feed algorithm with images with type and location of defects or weeds, and let the model learn how to locate them after it has been trained. It's worth mentioning that defects, whether it is a disease or weeds, can be challenging to detect even by human inspectors and also time-consuming. So improving automation, increasing efficiency, and maintaining high quality in production are more than welcome. For the weed detection operation, Deep Weeds dataset is a good starting point. It's the first large public multi-class image dataset of weed species from the Australian rangelands, allowing for the development of robust classification methods to make robotic weed control viable. So when we have a multi-label image segmentation problem, as it's the case here, we generally use a binary classification model to filter images with defects from those with no defect. And then we use as many segmentation models as the number of classes of defects we have in images. A very common way to build binary image classifier is to use convolutional neural networks. So these are special types of machine learning models that are inspired by how we humans recognize images. So CNN is trained to classify images by detecting some patterns just like us. For example, in the case of facial recognition problems, the patterns will be like ears, eyes, colors, and hairs, and so on. And in this image, the low level features such as small bands, lines are extracted at the initial convolutional layers of the CNN network. And when we go from layer 1 to the middle layers of the neural network, middle level characteristics such as nose, eyes, lips are learned, and the last layers of the network extract and learn the characteristic of an entire human face. So in practice, very few people train an entire convolutional network from scratch because it is relatively rare to have like a data set of sufficient size. So instead, it is common to pre-train a convnet on a very large data set, such as ImageNet, and then use the convnet either as initialization or a fixed feature extractor for the task of interest. And this process is referred to as transfer learning. So transfer learning is a machine learning method that applies the knowledge from related but different domains to target domains. And this solves the problem of having few or even not any labeled data in target domain. And of course, there are many flavors of CNN, such as VGGNet, Inception, ResNet, or Exception, that can be used for pre-training. Now that we built the binary classifier to distinguish weeds and diseases in images, let's dive into image segmentation to accurately locate anomalies in plants. So in computer vision, image segmentation is the process of partitioning a digital image into multiple segments. The goal of segmentation is to simplify and change the representation of an image into something that is more meaningful and easier to analyze. Image segmentation is typically used to locate objects and boundaries such as lines, curves, etc. in images. And more precisely, image segmentation is the process of assigning a label to every pixel in an image such that pixels with the same label share certain characteristics, and this will make it easy for the computer to learn from patterns in these multiple segments. So for example, each pixel belonging to diseased plant is color red here. The second project I'll be introducing in this keynote is related to road safety. It's a research project funded by the Ministry of Transportation here in Morocco in collaboration with the National Center for Scientific Research. As you already know, road traffic crashes are a major concern worldwide, resulting in great loss of lives and economic damages. And in Morocco, the situation is critical and the statistics are alarming, with thousands of fatalities reported every year. Road accidents are also devastating to the economy, and especially the Moroccan one. They cause an estimated 2.5 loss in gross domestic product here in Morocco. There are many causes of road crashes, but studies report that the human factor is responsible for more than 85% of road accidents, while factors related to infrastructure, traffic volume, weather conditions, and vehicle characteristics do not exceed 15%. So a human driving behavior is a complex concept, and it usually delineates how the driver manipulates the vehicle in the context of the driving scene and the surrounding environment. In spite of the agreement on the prominence of traffic-specific human factors in understanding the complex concept of driving behavior, there is little agreement on their conceptualization due to influencing factor which complicates its description. And one of our aims is to pin down the concept of driving behavior. As such, in order to conduct a more reliable analysis of the driving behavior, diverse types of parameters falling under the vehicle driver environment have been taken into account, And this driver-vehicle environment, DVE, is based on the concept of joint cognitive system, where the dynamic interactions between driver, vehicle, and environment are represented in a harmonized and integrated way. Crash analysis is a complex mechanism affected by various contributing factors, including the vehicle telemetry, the driver state, the environmental factors. So road traffic accident prediction or rapid detection plays a crucial role in safety management and planning. So understanding under which circumstances road crashes occur and which factors lead to the likelihood of a car accident would have a substantial influence on developing efficient policy interventions and avoid accidents from happening. Within this context, several real-time road crash prediction strategies have been outlined, which is expected to add to the current knowledge in the field of traffic safety. The further boost of models performance requires the systematic assessment of crash strongest precursors within the DVE context, and that's what we did in this project. In our project, studies were carried out using a fixed-based driving simulator located at Qada'iyad University. The adopted route layout in all experiments aims to simulate various aspects of real-world driving entails in order to explore the impact of the factors on driving behavior and the occurrence of crash events. Simulator driving studies confer significant advantage of imitating conduct in a safe environment with a full empirical control over driving conditions, including all types of weathers, ground, traffic, and most specifically in crash assessment studies, which cannot be conducted in real trials. Several volunteers were invited to the driving simulation sessions, and raw data was continuously recorded using the simulator. Our objective was threefold. We wanted to identify the strongest factors contributed to the likelihood of crash instances across various route geometries under adverse weather conditions using comprehensive real-time data. And we want to examine the effects of road geometric characteristics, weather patterns, vehicle telemetry, and driver inputs on the occurrence of crash events. And we wanted to develop multiple prediction models and select the best ones. So the figure on the right displays the complete process. We established 5 feature combinations based on 4 distant data inputs: road geometry, driver inputs, weather status, and vehicle kinematics, in order to compare the performance of the adopted models with different inputs. We aim to develop crash prediction models by considering the most pertinent inputs, create relevant features combinations, and develop efficient machine learning techniques. In general, collision avoidance systems, which are implemented to predict accidents, ensure warnings to drivers, or perform autonomous decisions, are deemed to be closed-loop systems, which can be seen here in Figure A. In collision avoidance systems, vehicle telemetry is continuously collected during the driving process, then forwarded to the algorithms which assess the current risk level, and then decisions are made afterwards in attempt to take the appropriate interventions. However, the existing collision avoidance systems and its crash analysis rarely examine the impact of drivers' state along with weather status on crash occurrences. Therefore, to further boost the predictability of crash events, one promising procedure is to systematically evaluate the situational hazards of vehicle, environment, and driver within a fusion framework, as exhibited here in Figure B. An abstract overview of the fusion framework is presented on the left figure. So once raw data is collected from the simulations, a pre-processing step is made to handle data imbalance and choose the most pertinent variable for crash analysis via feature selection. And then we construct a fused model to predict crash events. For data collection, a non-invasive smartwatch was also used to record physiological signals of heart rate variability, while driver inputs vehicle telemetry and weather conditions were obtained from the driving simulator. And the results provide new information on crash prediction and can be used to promote enforcement systems that enhance road safety. And here is a short demo of how our rail road crash prediction system works. So it estimates risks in real time and alerts driver. And you can find more info about our project, including our published work, on this website. The second project I want to introduce is a project to which I'm connected on the human level. It's actually an adversarial stuttered speech autocorrection and generation system. And I was actually honored to be a reviewer of a PhD thesis of a very special person who defended her PhD last year despite her handicap. So let me first introduce Latifa Raji, and you'll get a better idea of what I'm talking about. Latifa suffers from cerebral palsy and has disfluences in her speech.
في مجال المعلوماتية
يمتع السطن وسعيد الدكتوراه حول حماية أنظمة الأندرويد كان مسار طويل قبل ما نوصل لهذا النهار.
So in this project, we provide no medical nor psychological study about the source of the problem, but we built a deep learning framework capable of correcting disfluences in speech and generating new version of the speech, which is fluent and easy to understand. So the framework uses Generative Adversarial Network, or GANs, which is one of the most powerful types of neural network architectures for generative modeling. We focused on stuttering, which is a speech disorder causes discontinuity in the flow of sound. And the idea of this project is to convert the stuttered speech to a fluent version so that Latifa can only speak through some device and the device would output a corrected version of her speech. And to attain the mapping that can transform stuttered speech to a fluent version, we have recorded and collected speech data of stuttered speech and their corresponding fluent speech. And the speech in our datasets includes many speakers with different languages, including English, French, and a Moroccan dialect. And those speech samples were later pre-processed, which means sampled and converted to spectrograms to extract features that contain intensity information of time varying spectrum. And in this project, we used a version of GAN called Conditional Generative Adversarial Network, or CGAN. And those CGAN, as I said, are one of the most powerful GAN architectures. And in GAN architecture, we have two models that stand together in an adversarial way. We have a generator, which tries to generate samples that look like real world data, and we have the discriminator, which tries to distinguish between the real data and the data generated by the generator. And here is a demo of how the system works. Of course, there is a lot of room for improvement. We need more volunteers and more stuttered speech data so that we can improve our model and do more for the people suffering from speech disorders. This is the stuttered version of the speech. This is the target version. And this is the version generated by our model.
Where the filter bank is based on the behavior of the basilar membrane.
This is the stuttered version.
Where the filter bank is based on the behavior of the basilar membrane.
This is the target.
Where the filter bank is based on the behavior of the basilar membrane.
And this is the generated version that our system generated. So, to wrap up this talk, I think that AI is a wonderful revolution and it's already altering the way we perceive the world around us and raising important questions for society, the economy, and humanity as a whole. However, we need to understand what we want from AI and to tailor our methodology to those needs. We should also continue protecting important human values, maintaining mechanisms for human oversight and control, guarding against AI biases, and penalizing malicious AI behavior. AI needs to solve problems for all of the human equation, not just the privileged, not just tech giants, and not at the expense of those without access. It's also important to make AI accessible, inclusive, and understandable by all. Identifying the right problems to solve with AI will of course require a diverse group of people and experiences shaping its future. And to achieve that, technologists need to think outside of the technology box and start asking better questions. How can AI create value? How can AI fight unemployment and poverty? How can AI fight social disparities? How can AI build a resilient economy? And how can AI guarantee decent living? How can AI make this world a better place to live? And delegates can meet me in the speaker lounge for additional Q&A. And thank you very much for your attention.